Hello everyone. I am Giridhari Deogharia, Assistant Professor of Mathematics in the Department of Applied Science Humanities at Convergence. Today I am going to discuss about sequential series lecture 2. In the lecture 1, I have discussed about the basic concept of sequential series and some convergence tests like comparison test of type 1. Today I am going to discuss about the comparison of type 2 and examples, DLMS ratio test, Cauchy's root test and Raabe's test. Now, first recapitulate the lecture 1 and let's see the key concept we have taken from lecture 1. Now, we all know that this is the basic definition of infinite series where the first term is a1, the second term is a2, the third term is a3 and so on. And an infinite series can be written in this form: summation of n where n tends equal to 1 to infinity. N ranges from 1 to infinity. Now, in the lecture 1 we have discussed about two standard infinite series. First is geometric series and the second is P series. Geometric series can be written in this form, but the first term is a, the second term is ar, the third term is ar square and the fourth term is ar cube and so on. Here we all know that r is actually common ratio. Here, this kind of series can be convergent if mod of r less than 1. The value of mod of r less than 1. And this will be divergent if mod of r greater than or equal to 1. Now, if we take an example of the series, infinite series 1 plus 1 by 2 plus 1 by 2 square plus 1 by 2 cube plus dot 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 dot, then we simply tell that here the common ratio r is actually equal to 1 by 2, which is less than 1. So this is actually a convergent infinite series because mod of r less than 1. Now next standard infinite series is P series, where summation of n can be defined as summation of 1 by n to the power p, or this can be written as 1 by 1 to the power p plus 1 by 2 to the power p plus 1 by 3 to the power p plus so on. And if we take the infinite series 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus dot 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 dot, then p is actually 1. And this kind of series will be convergent if p greater than 1 and divergent if p less than equal to 1. Here for this infinite series p is actually 1. So this is actually a divergent infinite series. Now, if we take an comparison test of two series n and bn, both are of positive terms, and if n is actually less than equal to bn for all n, then comparison test told us that bn will be convergent if n is convergent, and n will be divergent if bn will be divergent. These are the key concepts from the lecture 1. Now we are going to take an example from comparison test of type 2. So this is the example where we can check the convergence of this series. First we have to find the nth term of this series. Here a is actually equal to 1 into 3. Remember that this dot is actually multiplication, 1 into 3 or 1 into 3 into 5, 1 into 3 into 5 into dot 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 2 to the the power n minus 1. If we put n equal to 1 here, we will get the first term. If we put n equal to 2 here, we will get the second term 1 into 3. If we put n equal to 3 here, we will get the third term and so on. So this is the nth term here. Now we all know that 1 by 3 is actually less than 1 by 2, 1 by 5 is less than 1 by 2, 1 by 7 is less than 1 by 2. Now if we replace 1 by 3 by 1 by 2, 1 by 5 by 1 by 2, 1 by 7 by 1 by 2 and so on. So there are n minus 1 number of 2's. So that's why we are taking Bn as 1 by 2 to the power n minus 1. There are n minus 1 number of 2's in the denominator of that infinite series. Now here n is less than or equal to Bn for all n? Yes or no? Okay. Now summation of Bn is actually summation of 1 by 2 to the power n minus 1, and this series can be written as 1 plus 1 by 2 plus 1 by 2 square plus 1 by 2 cube and so on. So this is actually a geometric series with common ratio r is equal to 1 by 2, and it is actually less than 1. And if the common ratio is less than 1 for a geometric series, this will be a convergent series. And that's why from the comparison test, A is also a convergent series. Now we are coming to the comparison test of type 2. If we consider two positive terms, two series with positive terms, which are an and bn, and the limit n tends to infinity, an by bn is actually l, where l is a non-zero finite number. L is a non-zero finite number. Then an and bn are convergent and divergent together. Means if an is convergent, then bn is also convergent, and if bn is divergent, an is also divergent, and vice versa. Now if l is equal to 0, if n is equal to 0, then a and bn will be convergent together, but not divergent together. May or may not be divergent. Okay. And if l is equal to infinity, then a and bn divergent together. A and bn divergent together, but may or may not be convergent. Okay. Okay. Let's take an example. So this is the example. Check the convergency of 1 plus 1 by 2 square plus 2 square by 3 cube plus 3 to the power 3 by 4 to the power 4 plus 4 to the power 4 by 5 to the power 5. Here the nth term of this series is n to the power n by n plus 1 to the power n plus 1. Now to apply comparison test, we are taking an infinite series. Summation bn is actually summation 1 by n. So bn is actually 1 by n. Now to apply comparison test of type 2, we are taking a limit n tends to infinity an by bn. So we are getting this type of terms here, and after simplify, we will get limit n tends to infinity 1 by 1 plus 1 by n to the power n into n plus 1 plus 1 by n. This will give the value 1 by e. So this is a non-zero finite term. So from the comparison test of type 2, an and bn are convergent and divergent together. If bn is convergent, then an is also convergent. Now here bn is a divergent series because p is equal to 1. This is a p series. Bn is actually a p series because bn is actually 1 by n, 1 plus 1 by 2 plus 1 by 3 plus so on. Then p is actually equal to 1. This is a p series with p is equal to 1. That's why it is a divergent series. Now from the comparison test of type 2, an and bn divergent together, so bn is divergent, so an will be also divergent series. Okay, so now come to another convergence test, which is D'Alembert test, which is D'Alembert ratio. Let us consider and sequence summation n of positive terms where limit n tends to infinity n plus 1 by n is L. Limit n tends to infinity n plus 1 by n is equal to L. Then the series converges if L less than 1 and diverges if L greater than 1. And if L equal to 1, test false. Let's take an example. Here is the example. Okay, let's try to solve this. Try to find the nth term. N is equal to what? N to the power p by n factorial. If we put n equal to 1 here, we get the first term. If we put n equal to 2 here, we will get the second term. If we put n equal to 3 here, we get the third term, and so on. So n plus 1 will be equal to n plus 1 to the power p by n plus 1 factorial. So limit n tends to infinity n plus 1 by n gives, but this will give limit n tends to infinity n plus 1 to the power p by n plus 1 into n factorial. We can write that by n factorial to the power n to the power. So this and this will be cancelled. So this will give limit n tends to infinity one plus 1 by n to the power p into n plus 1. This is actually 0. This is also actually 0. This will give 0, which is less than 1. L is actually less than 1. L is actually less than 1. So this is a by D'Alembert's test. This is a convergent series. Yes or no? Okay. Now we are coming to some examples. Here, this is a very important example for your exam. This is also a very important example. Okay. Now come to the next part, which is Cauchy's root test. Here we are taking an infinite series n such that limit n tends to infinity n to the power 1 by n is equal to L. Now n will be convergent if L less than 1 and will be divergent if L greater than 1, and this test false if L equal to 1. Now this is an example. Let's find the nth term of this series. Here n will be n plus 1 to the power n plus 1 by power n plus 1 minus n plus 1 by to the power minus n. Now from the Cauchy's root test, limit n tends to infinity n to the power 1 by n is actually equal to what? This will be equal to n tends to infinity 1 plus 1 by n to the power n plus 1 minus 1 by 1 plus 1 by n to the power minus 1, and this will give actually limit n tends to infinity 1 plus 1 by n to the power n into 1 plus 1 by n minus 1 plus 1 by n. This inverse. This will give what? Here this limit is actually e. This limit is 1 and this limit is 1. So this is actually e minus 1 to the power minus 1. Okay. And this value is actually less than 1 because the value of e lies between 2 and 3. That's why the total value is actually less than 1. That's why this is convergent due to Cauchy's root test. This is a convergent series by Cauchy's root test. Okay, now come to the last. Okay, these are the exercise. So this is a very important problem for your exam, and this is also a very important problem for your exam. Now come to the last part of this lecture, which is the Raabe's test. Let us consider an infinite series an of positive numbers such that limit n tends to infinity n into n by n plus 1 minus 1 is l. Then the series n converges if n greater than 1. For this case, for l greater than 1, this will be the series will be convergent, and for l less than 1, the series will be divergent, and for l equal to 1, test false. Now let's take an example, which is this. The first term is 1 by 2, the second term is 1 into, here the dot means multiplication, 1 into 3 by 2 into 4 and so on. Okay, so let's find the nth term. So nth term will be n, which is equal to 1 into 3 into 5 into dot 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 2n plus 1, 2n minus 1, sorry, 2n minus 1 by 2 into 4 into 6 into dot 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 2n. So n plus 1 term will be 1 into 3 into 5 into dot 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 2n minus 1. After that 2n plus 2. If we put n plus 1 in the by replacing n, we can get 2n plus 1, and here the denominator will be 2 into 4 into 6 after that 2n into 1 plus 2. Here limit n tends to infinity, n plus 1 by n will be what? This will be limit n tends to infinity. What will be the value? This and this will be cancelled. So here will be the first term will be this. So this will be 2n plus 1 by 2n plus 2. This will give actually a limit n tends to infinity 2 plus 1 by n by 2 plus 2 by n. This will give 2 by 2 to 1. So L is actually equal to 1. So D'Alembert test false. Now let us apply Raabe's test. Limit n tends to infinity, n into n by n plus 1 minus 1. So n by n plus 1 का वैल्यू क्या है यहाँ पर? This will have the value n into 2n plus 2 by 2n plus 1 minus 1. Limit n tends to infinity, n into what will be the value of this? 1 by this will be cancelled, 2n plus 1. This is actually the value. One by 2 plus 1 by 1. This will give the value of the limit 1 by 2. That is less than 1. So by Raabe's test, the given series is divergent because L is actually less than 1. So these are some exercise. This exercise is very important. This is also a very important problem. So this lecture will continue. We will get in touch in the lecture 3 of sequences. Thank you.